from that previous video, the value of Z, I couldn't look up the tables because they were on my laptop, which is recording, but the value of Z what turned out to be, if you remember, you had the Z minus Z or a Z here, and we put the corresponding Z here, and we wanted this area to be 75% or 0.75. So you had to go into your tables and look for 0.75 and then find the corresponding Z value. Well, that turns out to be, when you go into the tables, there's not 0.75, but there's 0.7518 or something, and there's 0.7486. So the closest is this number. This is the closest to 0.75, and that corresponds to a Z score of 0.67. But what they did do in the marking scheme is this would correspond to 0.68. So they sort of said it's somewhere in the middle, so it's 0.675. So whether you use the Z value of 0.675 or the Z value of 0.67 is not that important, okay? They give you both answers. I think the answer was 199.85 if you use the 0.675, and it was 199. I don't want to waste time here. 199.95 if you used 0.67. Okay. Right. I want to move on. Any other questions on that you can ask me on Monday. Okay. Right. So the next part, the next question is test the hypothesis at the 5% level of significance. No, I think have I actually done that? No. The next bit is 1 month later, 100 students or 100 patients were randomly selected. So a month later, so a month ago, they knew that the mean was 210 and the standard deviation was 15, a month ago, of the actual population. A month later, they're taking a sample of 100 students. So N is 100. They find that the mean LDL is 208 and the standard deviation of the sample is the same as it's 15. Okay? Now, using the sample mean, find a 95% confidence interval for the mean. So you want a 95% confidence interval. So you know that for the entire population at this time, if you were to take every single possible sample of size 100 and plot the distribution of the sample means, the mean of that distribution would be the actual mean of the population at the time, and the standard deviation would be the standard deviation of the population of that time divided by the square root of n. Okay, so in this case that's called sigma x bar, and that is equal to 15, because we don't know the actual sigma, but we know this is 15, so we use the 15 divided by the square root of 100. So that is 15 over 10, which is 1.5. Okay, so sigma x bar, the sigma of this standard deviation of this distribution is 1.5. Okay, now let's take our population, or our sample mean. So our sample mean, that's our x bar, is 208. Now we don't know whether the 208 lies here or here. Okay, we want a 95% confidence interval of where the actual mean will lie. So we either take 208 plus 1.96 sigma x bar. Okay, so we go that way, and we know our mean should be inside that if our 208 is to the left of the mean. But if our 208 is to the right of the mean, then the mean should be inside 208 minus 1.96 sigma x bar. Okay, now sigma x bar is 1.5. So when you work this out, you're going to get your mean based on your sample. It is suggesting that you can be 95% confident that the mean of the population at that time should lie between the interval of, I don't know if they have it here, 205.06, 205.06 and 210.94. So that's your 95% confidence interval. The next part says test the hypothesis that the mean has not changed in that period of time. So between when we looked at it and actually worked out the mean of the population, which was a while back when they did, has the mean changed between here and here? Well, 210 does lie inside this interval. So because 210 lies inside the interval that has been created by our sample, then we can say, no, it hasn't changed. Now, they do ask us to state the null hypothesis and the alternate hypothesis. So our null hypothesis is the mean is still 210. It has not changed. The alternate is that the mean is not 210. Okay? And from here we can see that the mean of 210 does still lie in that interval, so we can conclude that nothing has changed, and our mean is 210 still. Nothing has changed. That's our conclusion. We fail to reject H0. Okay? Right, the next bit. Find the p-value of the test that you have just carried out. Okay? So, the p-value, remember, the p-value is the area, the combined area of the 208. The p-value is the area of these two added together. So what we need to do first is, well, actually I'm drawing 208 on both sides. It's not on both sides. Okay, so we now know that if 210 is still our mean, 208 lies here. We want to see what is that area there doubled. That's what the p-value always represents. So to find that area, we basically need to find the z-scores. Find the z-score that corresponds to the 208 here. Find the z-score and then figure out, obviously there'll just be a plus z and a minus z. Figure out the area of those two added together. In other words, double one of those areas. So let's find the z. So 208 minus 210 over the square root, or over sigma over root n, which is over 1.5. That's going to give us the z-score, and the z-score for that is minus 1.33. So that z corresponds to minus 1.33. That z then would be 1.33. Okay, so we want the area, the sum of both of those areas. So we need to find the area from here back using our tables, subtract it from 1 to give us that area, and then double it. So the area from here back is the probability that z is less than 1.33, which is 0.9082, 0.9082. That's from here back, so we subtract it from 1 to get that. So 1 minus 0.9082 is 0.0918. Okay, that's this one of these areas here. We then have to double that, okay, and get 1.1836. Okay, and that gives us a number that is a lot greater than the 0.05 that we would have needed in order to reject the null hypothesis. So what we're saying is the combined area of those two is 0.1836, which is 18.36%. So we are well within the 95% interval. If we were outside the 95% interval, just at the 95% interval, that area plus that area would have to add to 5%, and your p-value will be 0.05. So this is dramatically more, so we are well inside our 95% interval. What did they say? Explain what this value represents in the context of the question. I think I've just done that. Yeah, no, that's fine. If I need to go into that in a bit more detail, I will. But basically, the p-value there is way above 0.05. So we will not reject the null hypothesis. hypothesis. Okay.